Located in Woodland Hills, Los Angeles, this former yacht factory turned film studio needed more than an upgrade. It needed an innovative foundation solution that could support decades of future film and television productions, all on top of a seismic zone. Working closely with engineers, contractors, and city officials, Jack used Helical Piles to tackle unique challenges under tight timelines, because the show must go on. Our job site sits on more than just city ground. It rests on a known liquefaction zone. Liquefaction is what happens when loose, water-saturated soil loses its strength during an earthquake, turning solid ground into something that behaves like quicksand.
Liquefaction, no matter what part of the country or what part of the world you're in, is going to behave the same. And it's like if you're at a lake or a beach and you start tapping your toe to the sand, it's saturated sand, so it turns kind of like a jello. That's liquefaction.
In a major seismic event, buildings without proper support can shift, sink, or even collapse. That's why California building codes require special engineering in areas like this. But until recently, helicals were not approved for use in Los Angeles. It took years of testing, engineering reviews, and close work with city officials to demonstrate that this deep foundation system could meet and exceed the rigorous seismic standards required here. Back at the job site, extensive pre-construction testing is underway. Testing the product on site ensures safety and peace of mind. This load testing is like a dress rehearsal, proving that the installed product can carry twice the design load. Once testing is complete and capacities for the piles are demonstrated, installation can begin.
Those 408 3.5-inch piers, those were all underpinning piers in the mezzanine, I believe, and on the perimeter.
The underpinning was all for not necessarily to stabilize. They weren't worried about that. It was all the additional loads that they were going to be putting on by putting on the extra story on the building. And those were underpinning existing foundations so they could take additional load and the seismic upgrades. And then we also had 4.5 new construction piles that were for new construction caps or new column locations. And then we had the battered piles on the exterior, which were 4.5 battered, and those were to address the lateral loading. So according to the solution software, piers should have ran about 55 foot deep. There was a hard lens right at 55 foot, but then right below that, we broke through and we had piers going in excess of 100 feet.
When you're putting that much steel on the ground and you have those kind of overruns, it adds up in a hurry. One of the things we had to do was change our helix configuration, minimize the overrun cost to the owner.
We originally had 16 weeks allotted in from the GC, and as we started to kind of get everything pulled together, like we can get this maybe 12 weeks, I think is what we had figured. And then, you know, the guys pushing through and working 6 days a week and the full effort for all 12 hours a day or more that they were working, we were able to get it done in 9 weeks. I'm proud of how they did it. You know, they did it safely. Super excited that we're able to expedite the job. We actually put almost 2 months back into their schedule to allow for other delays or problems they may have that occurred with the project. So GC was very pleased with the outcome, very pleased with the workmanship of the guys, the cleanliness and safety. So that was great feedback.